Okay. Just a minute. Yeah. Guys, we'll start now. We'll be just starting my workspace. And also I'm going to start the document as well. Okay, first we'll start the workspace and then document. Let's move on to the document. So this is a collections document, guys. Uh, we discussed about map related things. What are the methods of map interface? We discussed about what? Methods of map interface. We discussed about what is the hierarchy of the map interface and hash map, linked hash map, and hash table. These are all the different classes. Actually, concurrent hash map is missing in this. I will give you separately about that. That the concurrent map is an interface extends map interface. Concurrent hash map is a class which implements concurrent map interface. So basically, those things are missing in this, but okay, I will cover in the next diagram as well. So now we are understanding about what are the methods that we discussed here in the last class. That is called a key set. The second one is values. Next one is entry set. These are the three methods I've explained you. Remaining all okay. Put, remove, get methods are there, and the isEmpty method is there. Contains key method is there. Maybe that is missing in this. Contains key verifies whether this key is present in the map or not. That's what contains key method, and which makes boolean value like true or false. If the key exists, returns true. Otherwise, returns false. That is what contains key method. Okay. So how does a key value pair will be stored in a map object? That we discussed earlier, this because we discussed about a hash set. At the time of hash set, I told you internally hash set uses what? Hash map object internally. We discussed about such kind of things. What's the default load factor, initial capacity, these things all we know. So that's why we no need to worry on that. Okay. What's the difference between a hash map and linked hash map? Hash map doesn't maintain elements in order, insertion order. I told a hash map doesn't maintain elements in insertion order. But linked hash map will maintain the elements in insertion order because linked hash map contains what? A key value. Along with that, it also maintains previous pointer and next pointer. So this concept again I need to explain because I have already explained at the time of linked hash set. I told at the time of linked hash set, right? Same as linked hash set, linked hash map. Same as hash set, hash map. So there is no change. But here we have some additional methods. Okay. What are the additional methods we have? Like a key set, entry set, put, get, remove, and values. So we are going to look at about a program on that. But you know already how buckets are created, bucket index is calculated, all these things, because of we have already covered all these things at the time of hash set. Okay. Now we want to just create a sample example on hash map. We will store key value pairs in the map by calling put method. We can able to store the key and value pair. Here method name is not add. We don't have add method in map. In other collections like list, set, queue, we can add element by calling add method. But here element is nothing but what a key and value pairs, right? So we are going to write one program on that to understand about how to store key value pairs into map by creating hash map object. Then we'll see how to work with key set method. How can we call values method? And how can we get entry set? So we are going to look at about such kind of with example. First, we are going to look at about that example. Okay. Now, how does the key value pairs will be stored in map object? First, hash code of the key is calculated. Then bucket index is calculated based on the hash code. Then the element, the key value will be stored into that bucket. Am I clear? Then that element will be stored into that bucket, right? In the bucket index. That's how the bucket index is calculated. That is the way like how the bucket index is calculated, correct? Now I want to tell you something, guys. See, if for example, I want to store user defined class object as a key. Suppose I want to store a custom object as a key, not like an integer or a string. Then tell me for that object also, what is calculated? Bucket index is calculated. For that hash code is calculated. That's why if I want to store any object, custom object as a key, if I want to store any custom object as a key, okay, then I have to override hash code method and also have to override equals method. Two methods I need to override in the class, hash code method and equals method. Okay. If at all I want to store any custom object as a key in the hash map object, I need to override what and what methods, hash code method and equals method. Okay, right. I want to add that question. That's better. That is a better thing. I want to add a question here. The question is suppose, okay, suppose if I want to store a custom object as a key. Custom means user defined object as a key. Okay. What is required? Simple. Answer is simple. What's the answer? In the class, in the custom class means user defined class. Okay. In the custom class, not customer class, custom class means user defined class. In the custom class, you have to override hash code and equals methods. Hash code and equals methods. Okay, that's the answer. Okay, good. Now we'll start with program. Hash map demo program we are creating. I want to name it as a hash map demo program. Now we are in hash map demo program here. Guys, we are in hash map demo program. Now we want to create a new, then we want to create what, a class, right? New class. Sure, we'll start creating new class. We are in hash map demo program. Package name is com.ashokit.cf. Then class name could be hash map test with main. Now, just for example, observe here. For example, just for initial example is what? Hash map of integer comma string. Why I'm creating integer comma string? Why I'm passing two type parameters in hash map? Because The first one is key type. The parameter is a key type. The second parameter is a value type. First parameter represents what? Key type. The second parameter represents what? Value type. So integer comma string. Hash map of integer comma string. And let's say, for example, hash map equal to my variable name is also hash map, h lowercase, new hash map. Okay. My intention is what, for example, what is the key type here? Integer. Key type is integer, value type is string. I want to store a student number, rule number as a key, student name as a value. I want to store elements like student number, student name. Student number should be the key. Student name is the value. Okay, right? Let's see how to add hash map dot put is a method. Put is a method. Put of, for example, 101 is the key. Okay. For example, Satvik is a value. What is the meaning of this? Student ID is a key. Student name is a value. Key value. Key is an integer type. Value is a string type. Okay. Next, hash map dot put of, let's say, for example, 206. That is a one more student ID. Okay. One more student ID, that is. Okay. Let's say Mohit. Again, hash map dot put. Okay. Let's 105 is the student ID. Okay. Tanvish is the value. Hash map dot put, like this. We can store elements by calling put method, hash map dot put. Okay. 103 is the student ID. Okay. Let's say, okay, Lohit is the name of the student. So hash map dot put. Let's say 108 is the student ID. Okay. For example, Divya is the student name. Like this now. Now you can see hash map dot put. Null is the key. We can store null. Null is a key, null is a value. We can store null key, null value. Okay. So just I'm writing a comment here. You can store null key. We can store key null and value null. We can store, don't worry. I mean, it will allow null key and null value, but only one null key. If I again trying to add a null key, only one time the key will override. I mean, it is going to override the value, right? Okay. It is going to override now. For example, see hash map dot put. For example, null is a key. Then let's say value is Priya. Okay. What if I store the same key? It's going to be a duplicate key. I won't get any exception. But what happens now for this key, the previous value will be replaced with new value. Now for null, for the key null, the value is not null now. The value is Priya. Okay, right? What it will do? Overrides. Overrides the value of key null. Okay. It is overriding the value of key null because same key you are using 2 times. It won't give any exception, but it will override the value. That's what the meaning of adding like this. Next I'm writing like this, guys, hash map down footer. Okay, for example, 106 is the key, value is null. We can store. Now here, we can store duplicate null values also, no issue. Now hash map that put. Okay, for example, 103 already is there. Okay, it's there already, 103 with the value Lohit. Lohit is the name of the student. 103 is the key. Already we stored in the map. Map has the Lohit. Map has student ID 103, but again I'm using the same key. And if I pass value, okay, for example, in place of Lohit, I'm writing Lalit. Now Lohit will be replaced with Lalit. But my intention is, I don't want to replace. I don't want to replace. So there is a method available called, this is putna. There is a method available called put if absent. What's the difference between put and put if absent? If the key is absent, then only you want to store. Otherwise, you don't want to store. If the specified key not already associated or not mapped, then only you want. Okay.
If it stores null value, then it is replaced with Lalit.
Sorry.
In 103, if we have stored previously null value, if we have given, then will it be replaced with Lalit?
No. Thing is, it is not going to check for the value. It is going to check for the key. That's what put if absent.
Okay, sir. Okay, got it.
It is only check for the key. If the key not present, if the key is absent in this map, then only this key will be added. If it is already present, then it won't add. That's what meaning. So simple thing is what I want to write a comment here. So simply this pair is not added. So why this pair is not added? Because 103 key is already present. That's why. Now still our 103 contains value Lalit, Lohit only, not the Lalit. That's what the meaning is. Okay, next. Yeah. That's what the another method, put if absent. So suppose if you don't want to override, if that key does not exist, then you want to store that key and value pair in the map. And if the key already exists, then you don't want to store. If that is a key, guys, if that is a requirement, then you can call the method called as put if absent. Next. Now, okay, I can store null value, I can store null key, but key cannot be duplicated, value can be duplicated. Same value we can store for multiple keys. For example, I am writing one more, hash map dot put. I'll store, for example, 109 is the key, but the value is Divya. So value can be duplicated. The name of the student with the ID 108 is Divya, and even 109 is also Divya. So value can be duplicated. It is not overriding because the key is a different key. This is 109, this is 108. Both are two different keys. Okay, now next. Let's see how we can get all the keys now. System.out.println. I just want to say printing the keys of the map. We are printing the keys of the map, guys. We are printing what? The keys, only the keys. We are printing the keys of map. So how can I do that? How can I print only the keys of the map? Okay, cool. If I want to print only the keys of the map object, okay, first I need to get all the keys now. There is a method called as key set. I told you only keys we can retrieve by calling keys method, key set method. key set method returns a set of keys. The key type is integer. So set of integer, because keys are integer type. Keys set equal to hash map dot key set. Okay. Now you can use for each loop for integer x or k colon keys set. Then display the keys. System.out.println of k. Okay, if you want to print all the keys in one line, sure, print method you can call. Then give some space so that you can able to see all the keys in one line. Then I want to move the cursor to the next line. Or I just want to give some separator. First print /n, go to the next line, then separator. Okay, hope you got this. This is system.println stupid. Now this is only going to give you keys now. The method to retrieve only the keys is key set method. Now if I want to retrieve only the values, not the keys, only the values, then I told method name is values. Let's see, let's print only the values now. System.out.println printing the values of the map object. Printing the values of the map object. How can I set off? Sorry, not set. Collection. It doesn't return set. It returns collection. Collection of string. Because values are string type. For example, values collection equals to. What I can write? Hash map dot values. Yesterday I explained about what key set method will do, what values method do, and what entry set method will do. What values method returns? Values collection. What values method will do? Values method returns values collection. What can I do now? I can start working with for each loop to display one by one value. So for each string str colon values collection. What can I do? System.out.println. But I want to use print so that I can print all the values in one line. Just print str, then give a space. Again, one separator. Now let me first run this program. /n. Then like this. Now just see. Again, next I'll call entry set method. Currently I called key set method. I have called values method, but I also want to call entry set method. But before that, what this key set method returns only the keys of map object. All the keys of map object we can retrieve by calling key set method. Returns the keys of map object. This method values returns the values of the map object, right? So we just want to see whether this for loop is printing the keys and this for loop is printing the values or not. Now we can see here output, or the output here, output is like this. Printing the keys of map object. What are the keys now? Null, 101, 103, 105, something. These are all only the keys, right? Keys. Now these are values now. Okay, Priya, Satvik, Lohit, see Lalit, Lohit is there. Lalit is not replaced here. Tanvish, Null, Divya, Mohit. What are these all? These are all the values of map object. These are the keys of map object. Okay, now we'll do one thing. I want to display both key and value pairs. If you want to retrieve both key and value pairs, I told already there is a method called as entry set. Correct. There is a method called what? Entry set. Entry set method returns what? Key and value pairs. So I can go ahead with the entry set method. I can go ahead with the entry set method. Entry set method returns what? Key and value pairs, right? Entry set method. I can do entry set method now. Let's go ahead with the entry set. Set of first I let SOP statement. SOP printing key value pairs. Previously, what only keys are displayed. Second loop is values are displayed. Now both key and value pairs I want display. So how can I get that? I can't use iterator. Remember, if it is a list, if it is a set, or if it is a queue, if any one of the three objects, if they are a set object or if they are list object or queue object, I can use iterator. But if it is a map object, we can't directly use iterator on map. We can't iterate the map directly. Okay. We cannot iterate the map object directly. Map.iterator is not allowed because we don't have a iterator method in map collection. Okay, we can use iterator on set object, you can use iterator on list object, or you can use iterator on queue object, but you cannot use iterator on map object directly. Suppose if you call key set method returns what? A set. Key set returns a set of all the keys, right? Now you can use iterator because now you got a set object here. On this set, you can call iterator. On this collection, you can call iterator. But directly on this map, no, you cannot call iterator because you don't have an iterator on map. Okay, cool. Next thing, guys. I want to print the key value pairs of the map object, guys. I want to print the key and value pairs of the map object, guys. Okay, that's what we want to do. We want to print the key and value pairs of map. So how can I do that? How can I print the key value pairs of map? Sure. How can I do that? I can do like this. There is a method called entry set method. Entry set method returns map entries. You have to understand one thing, guys. Map is an interface, right? Map interface has a nested interface called entry. One entry represents key and value pair. I mean, which means basically you have to understand. We have an interface called let me tell you. See, guys, what I'm saying is we have actually an interface called map. Map is an interface. Inside the map interface, there is a sub interface called entry. It's a static interface. Static interface entry. Map is an interface, right? In a map interface, there is a static interface called entry. So we call map.entry because static can be called directly with the either class name or interface name. Map.entry. This is called interface in interface. Like we can add loop inside a loop. Like we know already nested classes. Like that, nested interfaces are also there. Nested class means we can define class inside class. Okay, right? Class inside a class, which is called nested class. Interface in interface, which is called nested interface. So map is an interface, entry is an interface, map.entry. We can able to do that, right? So what entry set method returns is these entry objects. These entry objects, nothing but map.entry objects. Each entry object contains a key and value. An entry object represents key value pair. Entry object represents a key and value. An entry is nothing but combination of key and value. Okay. So now I'm going to call, just observe it. What's the point is, I'm calling like this now, guys. What I'm doing is, I'll do this. What I'm doing is, set of map.entry of integer comma string, because key type is integer, value type is string. Let's say entries equal to, or map entries equals to whatever entries equals to. Or entries set equals to hash map dot. There is a method called what? Entry set. Practice this program today. Okay, entry set. What entry set method returns? Entry objects into a set. What entry object contains? Key value. Finally, entry set returns what? Key and value both. The complete element. The complete element is nothing but key and value. It returns key and value of an element as an entry into a set. If there are 5 key value pairs are there, nothing but 5 entries. Those 5 entries return into a set. Now we are getting what set of entries? A set of map.entry objects. I mean entry objects actually, but how can I write map entry, map.entry? I can even directly write set of entry also. But if I write set of entry, first of all, I need to import the map.entry. If I say Control Shift O, automatically imported. What you want to import? java.util.map.entry. Finish. Like this also I can write. If I don't want that map.entry here, just I want that entry, for example, then you have to import map.entry first. What this set now? The set of entries, entry objects. What each entry represents? Key and value pair. Who is entry? It is a static interface in map. It is an interface inside interface, which is called nested interface. It is a nested interface in what? Map. Okay. So now, what each entry? Each entry has key and value. Now iterate. How can you iterate? For each loop now, for entry, let's say for entry, let's say for example element colon entry set. Is the loop now? Now system.out.println. See, first I'm calling element dot get key. There is a method called get key from the entry object. Okay, this is called entry. I'm taking my entry reference is element dot get key. Key will be printed. Okay, plus I want to do one thing, dash plus element dot get value. Because entry contains key and value. How can you retrieve the key value? How can you retrieve the key and again then how can you retrieve the value? There are methods like a method called get key method. There is a method called get value method. So the method get key returns key. The method get value returns value. That's it. Now let us run this program. Okay, printing the keys of the map now. These are all, we know discussed already these two, but see the last one. Okay, null is the key, value is Priya. Actually, first I stored null. Null is the key, null is a value. But next I stored null is a key, Priya is a value. I told you that if the key is the same, it will overwrite. And you can see 103 Lohit is there. Actually, Lalit is not replaced here. Why? Because we called a method called put if absent. So if at all you don't want to override, then we can call another method called put if absent. That's a method. Okay. And remaining all same. I told you key cannot be duplicated, but value can be duplicated. Correct. So this is printing the key and value pairs of the map object. So how can you print both key and value at a time? Then you have to call a method called as entry set. Entry set method returns what? Entry set method returns entry objects, map.entry objects. What each entry object contains? Key and value pair. I'll let comment here later. Of course, I already gave entry set method, key set method, values method yesterday, but still again I'm writing entry set method returns a set of map.entry objects where each map.entry object represents a key value pair. Okay. Map is an interface and entry is a nested interface in map. Map is an interface and entry is a nested interface in map or nested interface of map. So we call it as map.entry. Okay, I guess. This will help you a lot. This is the program. I want to copy this program. Please go through this for your reference. This is the program, guys. This is the hash map. Similarly, you can create a linked hash map program. But you know, linked hash map maintains insertion order. Okay, first let me copy this. Here in hash map, what is happening? Hash map will maintain based on the it doesn't maintain the elements in insertion order, right? See, null we are inserting at very bottom, but we are getting an output very top. 109 we are inserting at the very bottom, but we are getting in the middle. So it doesn't maintain the insertion order. The key value pairs insertion order. If you want to maintain insertion order, then use what? Linked hash map. Because linked hash map will also maintain pointers like previous pointer, next pointer. So when the elements are inserted, they are linked with each other using previous and next pointers. That's how it maintains the insertion order. That's how it will maintain the insertion order. Linked hash map will maintain the insertion order. Hash map doesn't maintain the insertion order of the elements. That's the difference. Okay. So let me copy this into the document. The below example is to practice is a practice on hash map object. Okay, guys, please go through this example. Okay, so we got hash map. Okay. You know, difference between hash map and linked hash map. Let's start with the question. Again, same thing. Hash map object is not a thread safe object. Hash map object is not a thread safe object. There are 4 questions that we know previously with the list, set and all. The same questions again here we are going to copy. First, I want to add a question because we are not, creating another example with linked hash map. Just only difference question I'm writing. Hash map and linked hash map having only one difference. The difference is hash map does not maintain elements insertion order, but linked hash map will maintain the elements insertion order. That's the difference, right? For example, otherwise, the same program, instead of using hash map, I can use linked hash map. So as you can see, remaining code, everything same. Just only the change is instead of using hash map object, I'm creating a linked hash map object. Okay. That's called linked hash map. Okay. What is the data structure internally uses hash table? I mean, hash table means it's a table of key value pairs with a bucket index. That's what the meaning of hash table. Hash map, linked hash map, tree map, hash table class. They are all use internal underlying data structure is hash table structure. So linked hash map is what? It is a hash table and a linked list representation of map. Hash map is a hash table representation of map, but not linked list. Only hash table representation. Hash table is one data structure. Of course, we have a class called hash table. Hash table class also use underlying data structure is hash table. Hash map also uses hash table. Linked hash map also uses hash table. Hash table is one data structure. Okay. Linked list is one data structure. Last in first out is one structure. First in first out is one structure. Like this. The underlying data structure is hash table. Okay, hash map, linked hash map, tree map, hash table, all these classes will use underlying data structure is hash table. Hash table means it's a table of key value pairs. Each key value pair is called a bucket. Bucket has an index. And while storing the element, bucket index is calculated based on hash code. That is a data structure. Okay, that's why when I keep the cursor here, you can see you're getting a message saying that what hash table and a linked list implementation of map interface. That is called linked hash map. Okay, it will maintain insertion order. First I'm inserting element 101, next I'm inserting 206, next I'm inserting 105, next I'm inserting 103 into this map. Let's run this. Now we can see 101 after 206, 206 after 105, 105 after 103, 103 after 108, after that null, after that 106, after that 109. See, exactly in the same order we are getting the keys. Values also same. Satvik, Mohit, Tanvish, Lohit, Divya, Priya. Same order. Okay. See the output now. That is what it will maintain the insertion order. Linked hash map maintains insertion order. Now, sorry. Now this is the insertion order of all my key value pairs. But in hash map, you are not getting output like this because it doesn't maintain insertion order. Linked hash map will maintain the elements insertion order. That's the difference between hash map and linked hash map. Okay. Same program we can try 2 times. One with hash map, one with linked hash map. Observe the output, what you got for hash map. Observe the output, what output you got for linked hash map. Check who is maintaining the elements insertion order. Okay. I'll go ahead with writing a question. What is the difference between hash map and linked hash map? Difference between hash map and linked hash map objects or classes, anything. Answer is what? Answer is what? hash map is hash table implementation of map interface. I'll put this question answer like this. Okay, guys. Hash map is hash table implementation of map interface. Similarly, linked hash map is hash table and linked list implementation of map interface. Hash table and linked list implementation of map interface. So that is called linked hash map. Next. Okay, next. Hash map doesn't maintain elements insertion order. Linked hash map maintains elements insertion order. Okay, that's how we got the difference between hash map and linked hash map. Got it? Hash map doesn't maintain elements insertion order, but linked hash map maintains elements insertion order. This is the difference between hash map and linked hash map. Okay, guys. This is how okay, this is how we got it. This is the difference between hash map and linked hash map. Next, there are 4 questions. Let me copy the same questions from top. These questions we used for set, we use it for all, like the same questions, 4 questions are there. No? First one is thread safe or not. How can you make it a thread safe? Is it mutable, immutable? Yeah. These 4 questions. Okay. These I want to copy and I want to paste here. The same 4 questions. But change. Instead of hash set, hash map. No? Now, what's the question? Is a hash map object is thread safe? Answer is no, it is not a thread safe. No, it is not a thread safe. Okay, no, it is not a thread safe. So can you make hash map object as thread safe? Answer is yes. We can call synchronized map, not list. Synchronized map. Map is a method. Synchronized map method of collections class. How? We'll take hash map or map of employee. Map2 is equal to collections dot synchronized map of map1. Okay. Same questions. These questions will repeat. Next, hash map object is mutable or immutable? Answer mutable. Can we make hash map object as immutable? Answer is yes. Can we make hash map object as immutable? Answer is yes, we can call unmodifiable map method of collections. So map2 is equal to, guys, I'm writing for hash map. You apply it for linked hash map also. The same questions applicable for linked hash map also. I'll write a note. Cool. right? Let's go ahead. Let's go ahead, yes. Okay. Everybody, the same questions are applicable for what? Linked hash map also. So I'm not writing them. Same questions, 4 questions again, if you make, they are going to become linked hash map. Clear? Now, we know hash map, we know linked hash map, and we know the difference. Now, we have something called as hash table. Hash table is the next class that we are going to look at. I'll show you. There is a class called hash table. After hash table, then we'll go ahead with the tree map. So tree map we can discuss easily because you know tree set. Tree map will, tree map maintains elements in either natural sorting order of the keys, otherwise using comparator. You know, tree map is a implementation of sorted map, like a tree set is an implementation of sorted set. So you know tree map because of tree set, almost same. But hash table is a class. Hash table class extends dictionary class. Hash table also maintains key value pairs only. But there is a difference between hash map and hash table. I'll tell you that. These 2 classes we have completed. Hash map and linked hash map. Linked hash map extends hash map. Hash map implements map interface. We know this hierarchy. Next, there is a class called hash table. Hash table class implements map interface, but also extends a class called dictionary. Dictionary is one separate class. It's not a, it doesn't have any relation with the collections topic. It's one class. Dictionary is a class. So hash table class extends dictionary. Hash table class implements map interface. It also uses underlying data structure is hash table only. Hash table class uses underlying data structure is hash table. Hash map uses underlying data structure is hash table. Means hash table class also stores data in the form of key value pairs only. Okay. Understand the point now. Hash map, hash table, linked hash map, tree map, all uses what? Underlying data structure is hash table structure. Hash table structure means it is a structure where elements are key value pairs, and key cannot be duplicated, value can be duplicated, and bucket has an index. That is called hash table data structure, where key is to identify the value. We use the key to identify the value. Am I right? That's what I'm saying. These are all called as what I'm talking. All this comes under a concept of hash table data structure. Okay. Please try to get this point clearly, guys. Okay. Let's go ahead. So there is a difference between hash table and hash map. Actually, both will store key value pairs only, but hash table is thread safe object. Hash map is not a thread safe object, but hash table is a thread safe object. Because in hash table, all the methods called synchronized methods. It won't allow 2 threads to act on hash table at a time. If one thread is doing something on hash table, the other thread has to wait until that thread has completed the work. If the thread is calling a method, for example, a thread is calling a method on hash table to do something, then until that thread completes that operation, other thread has to wait. It cannot do any other operation. That's why hash table is called thread safe. But whereas coming to performance, hash table performance is less because of synchronized methods. Because I will explain how it is going to be. But let's talk about hash table now. Let's talk about a class called hash table. I'm talking about a class called hash table class. Sorry, hash table means only T lowercase only, H capital. Okay. As you know, the point is what? Hash table class extends dictionary class and implements map interface. Okay, it extends dictionary class and implements map interface. But one thing, hash table, also uses underlying data structure as hash table only. Hash table class uses the underlying data structure. Hash table class uses underlying data structure as hash table only. Okay, right? Hash table. Remember, this hash table H capital is class. This hash table is a data structure name. Principle, hash table principle. Data structure principle as hash table. That's what. Underlying data structure principle as hash table only. Both hash map, linked hash map, all they use this data structure principle. The principle of data structure is hash table. So hash table also maintains data in key value pairs. Okay. Hash table stores elements as key value pairs. Same. I no need of writing again unnecessarily the points. Same as hash map. But there is a difference. For example, you take hash map. We know hash map object is not a thread safe object, which means by default, hash map is not thread safe, which means what? Two threads can act on same hash map object and can do operations simultaneously. Right? That's why it is not a thread safe, which means what? If two threads are at a time performing operation on hash map object, then what happens now? One thread modified data may be modified by other thread also. The same data, the same key value pair at the same time. Correct? Maybe one thread modified data. Other thread also is modifying the same data. Nothing but what happens now, one thread changes are overridden by other thread. Correct? That's why it's not a thread safe object. But hash table is a thread safe object. Only one thread can do operations at a time. And let's open hash table. In hash table, all the methods are synchronized methods, which means if one thread is doing an operation on hash table, at the same time, the other thread cannot do the operation because the entire hash table is locked. That hash table object is locked because a thread is already performing an operation. And how it is possible? Because of synchronization. In hash table, all the methods are synchronized methods. So let's look at let's look at hash table class. If you look at hash table. So as you know that the hash table class extends dictionary. Dictionary just is basically a class. It is in java.util package, but it is not an implementation of map. Just it's a class which also stores data in key value pair. This class implements a hash table which maps keys to values. I mean, what is meant by this hash table? It is a data structure principle. Okay, right? Everybody? Same. See, an instance of hash table has two parameters that affect the performance: initial capacity and load factor. For the initial capacity of hash map object, 16, right? But here it is 11. Hash table has initial capacity as 11. There it is 16. Load factor is same, 0.75. Okay, 0.75. Let's see. You can see here, constructs a new empty hash table with a default initial capacity 11 and load factor 0.75. So it is 11, but in hash map, the initial capacity, default initial capacity is how much? 16. For hash table, it is 11. But here also what it will store? Key value pairs only. Okay, it stores key value pair only. At the time of creating hash table object, we can also pass initial capacity and load factor as and when required, whatever that we want. If initial capacity is less than 0, or if the load factor is non-positive, then you'll get this kind of exception. What exception? Illegal argument exception. Okay, illegal argument. Argument is illegal. Illegal argument exception. This is what I'm trying to say. And here also your methods. For example, I want to show the method is empty, key set, put if absent. Okay, and size, values, right? We have something like this, but we don't have an entry set method. Key set method is there. Where is entry set method? Yeah, we have the method here. Entry set. Same methods. Entry set method is there. Key set method is there. Values method is there. Is empty is there. Put if absent is there. Remove is there. Put is there. Get is there. Size. Same methods almost. Almost same methods that what we discussed in map, right? The same methods are available here also. Additional methods are there, but contains key method to check whether the key exists or not, returns Boolean value true or false. Okay. So basic thing is clear. Or the basic thing is clear. Hash table is a thread safe object. Hash table also stores data in key value pairs. Whenever you create an empty hash set object, empty hash table object, then it is created with a default initial capacity 11 and load factor 0.75. It is not 16, it is 11. That's the difference. It also maintains key value pairs, but it's a thread safe object. Right? So when an empty hash table object is constructed, then our hash table is created. Then hash table is created with the default initial capacity as 11 and the load factor as 0.75. These things we know already. See, what I'm trying to say now, guys, I will explain in detail. See, what I'm saying is, for example, this is hash table. For example, this is hash table, guys. And two threads are using the same hash table. They are not using their own hash tables. Both of them are using, this is a sharing object for both thread 1 and thread 2. Example, this is hash table. There are two threads. Thread 1, thread 2. So hope I'm clear with you. Hope I'm clear with you. I have two threads, T1 and T2. This is hash table. This is a hash table object. Now, how many threads are sharing this hash table object? Two threads are sharing it, T1 and T2. Both the threads are sharing this object. Am I clear? The two threads are sharing with this object, hash table object. T1 and T2 are the threads sharing this object called hash table object. T1 and T2 are the two threads. What happens if, for example, thread 1 is trying to put one element in the hash table? It's trying to put one element. Or it is trying to remove one element. When this thread is performing this operation, at the same time, this thread also cannot do the operation. It cannot access this object because it is locked. Because already T1 started operation put. Once T1's operation completed, T2 can do the operation. But at the same time, T1 and T2 cannot perform the operation on this object. So hope I'm clear with you. Now T2 should wait. Why it cannot perform the operation at the same time? Both the T1 and T2 cannot do the operation at the same time because this is thread safe object. It is synchronized. If, for example, first T1 has started operation, immediately T2 also started operation. Because of the first T1 started, it acquired a lock on this object. T1 has acquired the lock on this object. That's why T2 cannot perform operation until the lock is released. So when T1 completes operation, automatically lock is released. Now T2 can start working. But at a time, how many threads can perform operation? Either put or get or remove or any operation. Only one thread can do. That's why this is called thread safe object. But in hash map case, it is not like that. Hash map is not a thread safe. Two threads can at a time can use operations on that same object, can start doing operations. If allowed, what happens maybe if the first thread, second thread are modifying the same value, then what happens now? If two threads are exactly modifying the same data, then one thread made changes will reflect in other thread also. Okay. That's why hash table is thread safe and hash map is not a thread safe object. And moreover, the differences are very important. Today, I will write the difference between hash table and hash map. Okay. The question is very important. What is the difference between, this is the important question, hash map and hash table? Answer. So what's the difference between hash map and hash table? Difference is, hash map is not a thread safe object. First difference, number one. Hash map is not a thread safe object, but hash table is a thread safe object. But the hash table is a thread safe object. This is very important difference. Okay, how can you say that hash table is thread safe object? I'll tell you. If you look at the, I think it is there. If you look at the hash table methods, all these methods of hash table, let's say, for example, any method you take, for example, get method, or for example, remove method or put method, whatever it is. These methods are all synchronized methods. Put method, get method, all these methods are synchronized methods. Synchronized methods, I mean, they're thread safe. They don't allow multiple threads to perform operation at a time. That's what meaning of that. Okay. So we'll go ahead and get the concept now. I would like to write hash map is not a thread safe object, but hash table is a thread safe object. Second point is what? Actually, this is a very important question that you are getting. Next. Next. Hash map allows null key and null values, right? We can store only one null key, but multiple null values we can store. It allows null key and null values, but hash table doesn't. But hash table does not allow. If you add a null key, null value, it will throw null point exception in hash table. Okay, so hash table. Guys, but hash table doesn't allow null key or null value. It doesn't allow. No null key, no null value in hash table. It doesn't allow. What happens? It will throw null point exception. Coming to third difference. Okay, coming to third difference. So the third difference. Hash table. Sorry, hash map now. Hash map default initial capacity is 16, but hash table default initial capacity is 11. This is the difference between hash table and hash map. Okay, this difference is important. You try one example today with hash table. I'll share this document. You try the same example, one hash table example. I told hash map example. Now, similarly, you try hash table example. You add a null as a key or null as a value. Check, is it accepting them, or you are getting an exception called null point exception. You can check like that now. So same program of hash map, you can convert into hash table. Check whether you are getting null point exception or not. If you are getting null point exception, remove that nulls. Okay, then again try. Key set method, values method, entry set method, you can try all those things. Okay, so how hash table is thread safe is the next question. And with this question, we'll wind up the class. Okay. Then continuous is next tree map. So tree map is a very simple. We know already tree set. So tree map next I'll explain after this. Okay. Then I'll talk about concurrent hash map. So tomorrow we are going to complete the collections concept, and then we are going to look at about what are the new features in Java 8, important features in Java 8. Okay, that's what next we are going to look at. So first I want to, after that, then we'll discuss about remaining concepts like multi-threading, and there are some topics, package, cloning, serialization, reading and writing the data in files. So some operations are there. Okay, next, the question is, what's the question? How hash table is thread safe? Answer? You know what the answer? Hash table methods are synchronized methods. So hash table class methods are synchronized. So how many threads are allowed to access at a time? So one thread. Okay, hash table class methods are synchronized. So one thread can perform an operation at a time. So hash table object is thread set. Okay, this is how we can say. Okay, guys. Now I'll share this document with you. Okay, and continuation again. We'll discuss tomorrow. Tomorrow we'll discuss the continuation, but today I'll share the document now.